Hi everyone. So we are gonna do another two questions. So this was a target run. So we have 20 numbers, and then they have some information. So let's start with those. So we are given the mean is 11. So I'm gonna go with that. So the mean is 11, and the median is 14. Okay, and the range is also 14. And the unique mode is 19. So, and then if 6 is added to each number on the list, then all of the resulting numbers are double. The new mean will be A. So I'm going to just say A is something. And then the median, the new median will be B. And the range will be C. And the mode will be D. And then we are looking for those four numbers. So it is not too simple. It was number 4 on the target. So let's think about first. So first, I will say we may kind of come up with 20 numbers that actually satisfy that, but it will take a while, and then we do need to do this in 3 minutes or so. So I'm gonna start with something like this. Let's say we have A1, A2, A3, all the way to the A20. So let's assume A1 is the smallest, A20 is the largest number in the list. And if you're adding 6 to each number, before we do, maybe we should use some of the given information. We know the mean is 11, right? So that means if you add all of these numbers, like A1, A2, all the way to A20, so from here, I can say A1, A2, A3, all of these add up to 20. When you divide the sum of these guys by 20, then we do get 11. So if you multiply by 20, the sum of these numbers is just their sum. So A2, A3, A20. So this is equal to 20 times 11, which is 220. That is something. But the question was asking now, add 6 to each individual. Like if you increase each individual by 6, like this number will be now A1 plus 6, and then this number will be A2 plus 6, and then the last number will be like 20 plus 6, right? And the sum will increase, that some of these 20 numbers will be increased by 6 times 20, because we have 20 numbers, each number is increased by 6, so the sum will increase by 6 times 20. But at the same time, we are going to double these numbers, so we are going to have 2 times of these, basically. And if you multiply every single number by 2 and add 6 and then double after, so each number will be like 2 times as much plus 12. So you're going to double each number and then add 12 to each number, basically, because we are going to add 6 and then double after. So if that's the case, the sum of these numbers will be double, which is we had 220. And then you are going to double this number, which is going to give us 2 times as much. But we are going to add 12 to each number as well. So we have 20 of these numbers. So that should be increased by 12. And this is going to be some of the new numbers. And if I divide this sum by 20, I should get what I like. So I don't want to multiply. If I split these guys, so you should get 2 times 220 over 20 plus 20 times 12 over 20. So these will cancel, and then that will be 11. So 22 plus 12, which is just 34. So you could have gotten this a bit easily without really writing this algebraic work. I just did it so you can see it, but I'm going to leave the shortcut for you to explore. This is something. We got it. This was the longer part, I guess. The median, every number just increased by 6 and double. So the value of those numbers are changing, getting bigger. But at the same time, the middle number doesn't really change the position. So only thing is happening to middle number, you are multiplying the middle number by 2 after adding 6. If you do so, you will get just 2 times 14 plus 6, right? So that will give us 40. So the B has to be 40, and we got that. So AB is over. The range, think about the range. Range is the difference between the largest and the smallest. The smallest number is A1 and the largest was A20. So let's say A20 minus A1. This was given as 14. But now we add 6 to each individual. When you add 6 to each individuals and subtract, then those 6 will be gone as well. So which is why it doesn't really make any changes to my range. But at the same time, you multiply the numbers by 2. So you can kind of play with that as well if you want to. So you can just say 2 times a 20 plus 6 if you really want to convince yourself. This is going to be the new larger number, and the smaller one will be 2 times a1 plus 6, and then you're looking for this difference. And if you do so, you will get 2 times a20, which is the largest number, plus 12. And if you expand this, you will get minus 2 times a1 minus 12. As you see, 12s will be gone, so you will get 2 times a20 minus a1. So only thing that happened to the range is just double. So we had 14, so now we will get 28 basically, and that's the answer for this part. And the last one is mode. The mode, the number that appears the most, we were given that's 19. And if you're adding 6 to each of those numbers, the sum, like those numbers will increase by 6. That will give us 25. But you are going to double these numbers after adding 6, so you will get 50. And the number of 50s will be same as number of 19s that we have, which means the mode will be 50 as of now. If you write those in the given order, so we are going to be done. So that should be 40, that's 28, and that's 50. So it took a bit longer, but I hope that makes sense. I just kind of made a bit algebraic expression, so it could be a bit clear. But you could skip some of these steps. I'll see if you can challenge that yourself with those, okay? That was the first problem. So the second question we have now is a geometry problem. This is the question I choose because it's been asked. Also, there's a relation between these two triangles, which is I like to show them. So there's a right triangle, right? So this is a right triangle. As soon as I see a right triangle, couple of things that comes into my head. The Pythagorean is the first thing. If there are some maybe like parallel lines as well, I would think about similar triangle as well. But in this case, just Pythag is what I like. And the question's asking AB. Okay, so this is what we want. But I'm gonna make some sort of Pythagorean. If I use a Pythagorean in this CDE, so you will get CD squared plus DE square is equal to hypotenuse square, which is 6 squared. And if I use a Pythagorean in ACD, so the leg will be CD again. And then the other leg will be AD. And the hypotenuse is AC, which is 10 to the second power. And if I use the Pythagorean in this triangle, because I know the hypotenuse of EDB, so that will give us DE square plus DB square equals 9 squared. Okay, and then if I use the Pythagorean on ADB, so you will get AD square and DB square equals AB square. Like before I do this problem, I want you to go ahead and take a look at what I have so far and pause it and see if you can finish the rest, because there is a really nice relation going on here, so which you can explore on your own. But I hope you did it, and then I'll just resume, okay? So look at the equation. Like if you look at this equation, I have CD and DE. And if you look at this equation, I have DE and DB, right? But think about the other two. If I look at these two equations, I have CD, which was same as this one. I have AD, which is same as this one. And then I have DE, which is right there. And then I have DB, that's the same as right here. Meaning that if I add this equation and this equation, and add this equation and this equation, I will get the same sum. So let me show you that. So if I want to add the first and the third equation, so you will get CD squared and DE squared plus DE. Let me double check. DE is right there. We had DE as well. Okay, CD and DE, right? So CDE, that's gonna be 6 squared, and then CD and AD, that's given, and DE and DB, and then AD and DB, because it doesn't look like it's telling me the same thing. Let me double check. So if I add this one, I guess not with this one. The last one is probably the best one. So let me clear that piece. So like if I add the first equation, okay, so this one and the last one. So you have CD, and then you have CD on the second one. DE, you have D is right there. And then you have AD, same as this one, DB, same as this one. So if I add the first and the last, the sum will be equal to AD squared plus DB squared. This is equal to 6 squares plus AB squared. So 6 squared plus AB squared. And now if I add the remaining two equations, so CD and AD, and for the next one, DE and DB. And we have 10 and 9 squares, so that's 10 squared and 9 squared. But look at the left side. So the left side of these two equations, like we have CD, CD, DE, DE, AD, AD, BD, BD. So left side are equal. So which means the right side should be same as well. So from there, I can say 36 plus AB squared equals 100 plus 81. Subtract 36 from both sides. So you get 145. And if you take the square root, so you will get AB as the square root of 145. So you have to simplify if possible. So if you look at this number, so 145 is like divisible by 5. So let's check that. So if you divide by 5, so you will get 2. And then that will be 45, which is 9. So 5 and 29 is not anything you can simplify more because those numbers doesn't have a perfect divisor. So that's why this is going to be our final answer. So 145 on the square root. So the key like result from this exploration, basically, when you add look at what I have on the left side. So, you know, CD and DE. So like, which is going to give us those two sum is equal to square of this guy. And the other two, AD and DB, is going to give us the square of the question mark. So the sum of these two, like as a kind of final result, I will say CD squared plus AB squared is equal to sum of the square of these opposite ones. So the AC squared plus BE. You don't have to memorize it, but it's kind of cool fact that is going on. So that is the result. If you've seen this before, you could just skip all these Pythagorean stuff, then get the answer immediately. So if you kind of see this question next time, so you could just do this. You will say 6 squared plus question mark squared equals 10 squared plus 9 squared, and then you got the x as 145 on the square. That's it. So I hope that makes sense. I'll see you in the next video.